And we'll now move to part 2 of our data analysis, which talks about Wireshark. So for those of you who are new to Wireshark, Wireshark is a free and open source packet analyzer. It is probably the world's most popular packet analyzer. It is used for network troubleshooting, analysis. It's used for software and protocol development, and it's used widely in education. Wireshark is very similar to an earlier tool called TCP dump, but it comes with a graphical front end plus with integrated sorting and filtering options. So usually Wireshark is used to capture packets from a real network. So it'll capture real packets. In our case, NetSim has a traffic generator which generates virtual traffic during simulation. But remember that this virtual traffic is exactly the same as real traffic. It will have the same headers, it will have the same payload, and the packet structure and format will be exactly similar to a real packet, except that the payload will be something that the traffic generator would have virtually created instead of it being real payload. Then what you can do is you can run Wireshark in the nodes in NetSim, just as you would have run Wireshark on real devices, and you can do a live capture of the simulation packets. So we'll show you how you can enable this capture. So in NetSim, so if you right click on the device, you will see this option called Wireshark, where you can either disable this capture or you can set it online or offline. Online means it will be captured as the simulation is running. Offline means it will be recorded and then you can play it post simulation. So in our case, we'll select online and we'll click accept. Now Wireshark will run on node number 3, and Wireshark will capture the packets as node 3 transmits the packets to node 5. Now we'll run the simulation. So as you can see, Wireshark is opening up automatically. And the packets are getting captured as the simulation is running. Now, the details of the contents, so you can select any packet, and the details of the selected packet can be seen in the panes below. In the tree view, users can expand the data by clicking on that part of the tree and view detailed information about the headers, the flags, and so on. So this is, for example, the TCP headers. What is the port number? What's the destination port? What's the sequence number? What's the window size, and so on. So all the TCP parameters are there just as it would have been there in a real packet. And below that, in the pane below, you can see the packet payload in hex or bit format. So on the right hand side, we have our own virtual data, which is this ABCDEF GH, which is something virtually dummy payload created by NetSim. Now display filters will allow you to concentrate on the packets that you are interested in while hiding the ones that you are not interested in. So we filter and get a list of TCP packets. Now let's say we want to analyze this. So typically the way you analyze TCP is you want to send which packet was sent, what acknowledgement did you get, how was the TCP connection establishment done, and so on. To do that, you can go to statistics menu and then select on the flow graph. So here you can see that the TCP connection establishment happens initially. A SYN packet is sent for which a SYN ACK is got. Against that, the ACK is sent from the source, and then the data packet is sent. Again, you're getting data packet and ACK packets that are continuously there, and you can see the packet number and the sequence number. So this is very useful to analyze. Suppose you're writing your own protocol and suddenly somewhere you see that it is not functioning, you want to understand what is going on, you can very quickly run Wireshark and then see what happened to each of the flows. Here again, we have specifically architected NetSim in such a way that you can capture files in Wireshark and you can analyze them. Another useful plot is the plot of the congestion window. So this is the plot of the TCP congestion window. This is a standard plot that shows how the TCP congestion window scaled up and down as the simulation progressed. And each point on this graph represents the TCP congestion window at the time when the packet is sent. So you can then zoom in and you can observe that whenever there is an error, so initially the congestion window increases, and then whenever there is an error, which could be due to packet loss, or it could be due to expiry of the timer, which is probably an acknowledgement loss. So whenever any of this happens, the window drops to 1, and after each drop, the TCP Old Tahoe algorithm enters the slow start phase. So the initial phase is the slow start, where the window increases exponentially, and then it enters the congestion avoidance phase, where the window expands linearly. So this is like a standard experiment that most UG students will be doing, where they'll try to understand in the TCP IP stack, how does the TCP function, the TCP protocol function, how is the initial connection establishment done, and after the connection establishment is done, how does the protocol operate, how does the window increase. So initially it increases exponentially, then it increases linearly, and then whenever there is packet drop, packet loss, or timer expiry, the window falls to 1. And this is what happens in the real world. And similar to the real world, NetSim provides options for simulation packets to be captured using this industry standard network analyzing tool called Wireshark. So with this, we complete part 2 of the analytics that is there in today's seminar. In the first part, we looked at how you can analyze packet trace files. And in the second part, again, you can see that the Wireshark captures are again very large files running into thousands of packets, and each packet having its own sequence number, then the acknowledgements, then different packet sizes, different acknowledgement sizes. All kinds of complex things are happening in the network which NetSim simulates, and from all those complexity, if you want to make sense of all this data, then you can use the TCP Wireshark tool to figure out the TCP flow control and the TCP window scaling. So in case any of you have questions, you can just again write them down in the chat window, and we will we'll try to answer them at the end of the. Yeah, so we've had 2 questions. I'll just take a brief moment to answer. One question was asked about how the error packets were sent. So in the earlier example that we had shown you, so the question is, why were packets errored? And the reason for that is that if we show you the network in NetSim, you can see that the links had some bit error rate. So because the links had some bit error, which is 10 to the power minus 6 is the error rate that is set. This is the reason that we have a few packets that get errored, and hence the trace analysis showed that packets were errored. Second question is it possible to know how much energy is consumed? Yes, we have energy models, and you can figure out how much energy is consumed, and then when did the node die. You can also have things like energy harvesting and so on. Maybe at the end of this presentation, we'll spend a few minutes and show you some of the power models that are there in our sensor network module, where you can look at these things. Can random deployment be done? Yes, random deployment can also be done. We have we'll show that again at the end of this webinar. We'll show both the power models and the random deployment. So now going to the final section where we would like to plot different kinds of data. I think all of you know about Matlab. Matlab is a high performance language for technical computing, and Matlab has extensive facilities for displaying vectors and matrices as graphs, as well as annotating and printing these graphs. Now NetSim provides users the ability to interface with Matlab in runtime. So we have written some Matlab interface code that is shipped along with our software. So if you open our source code, you'll be able to see some of these things, and we have the Matlab interface, which is a separate file that we ship, and in this file you can initialize Matlab, then you can execute various Matlab commands through a .m file. You can get variables and send variables between Matlab and NetSim, and finally you can shut down the Matlab process. So what we will do is that we will show you now how this is used to plot the frequency utilization in a cognitive radio network in runtime. Okay, just before I start, there's another question. What is exactly the meaning of Wireshark? Wireshark is an open source network analyzer software. So if you just Google Wireshark, you will get the site which says www.wireshark.org. So Wireshark is a network protocol analyzer for Unix and Windows. So what we have done in NetSim is NetSim will link with this Wireshark, so that whenever you run NetSim simulations, you can interface it with Wireshark. Okay, there's another question on vehicular ad hoc networks. If you don't mind, I'll answer some of these questions towards the end of the webinar. We'll set aside 15 minutes where we will answer all your queries. Meanwhile, we'll just complete this bit on Matlab. So what we have done in this 802.22 cognitive radio network simulation is that we have a network which has two base stations. So you can see BSA and the other one BSD. Each of them, the first base station has two primary users and one secondary user. CRCP is the secondary user, incumbent is the primary user. And on the other side, you have one primary user and one secondary user. And the settings for this network is that the secondary user in base station 1 operates in a frequency of 54 to 78 megahertz, and the bandwidth of each channel is 6 megahertz. That means you will have channels 54 to 60, 60 to 66, 66 to 72 and 72 to 78, 4 channels. Similarly, the secondary user in base station 2 operates between 200 to 240 megahertz with a band of 8 megahertz for each channel. So the channel set would be 200 to 208, 208 to 216, 216 to 224, 224 to 232 and 232 to 240, 5 channels. We have just chosen this at random. These are all available in NetSim for the users to set the way you want. And then the primary user has something called operational time and operational interval. Operational time is the time at which it is on, and operational interval is the time at which it is off. So in the first case, we can see that the first primary user operational time is 5 and operational interval is 5. That means it'll be idle from 0 to 5, and then it'll run from 5 to 10, then it'll be idle from 10 to 15, then it'll run from 15 to 20 and so on. In the second case, it'll run from 5 to 10, then from 15 to 20, then from 25 to 30 and so on. And the first primary user comes on in frequency 54 to 60, and the second primary user comes on in the frequency 66 to 72. Whereas in the second one, the primary user is in frequency 54 to 60, whereas the secondary user is in the frequency 200 to 240. So as you can see, in the first base station you will have interference, because whenever the primary user comes on, the primary and the secondary user are operating in the same bandwidth or in the same frequency range between 54 to 78 megahertz, whereas in the second case the primary user is in a different frequency range and the secondary user is in a different frequency range. So there is theoretically no interference possible between the primary user and the secondary user in the second base station. Now there's something else called a probability of false alarm. What does false alarm mean? That even though the primary is off, the secondary believes that it is on, or even if the primary is on, the secondary believes that it is off. This is what is the meaning of false alarm. So in the first case we have set false alarm to 0, that means there is no false alarm at all, whereas in the second base station we have set a value of 1%. That means 1 in 100 times the secondary user by mistake detects a primary user when there isn't any. I mean, obviously a good detection algorithm will ensure that the probability of false alarm is as low as possible, and generally research is being carried out as to how to reduce this further. So in our case we have set this value to 1 in 1% and in the other case to 0%. Now what we will be doing is we have interfaced with Matlab and we have sent some variables from NetSim to Matlab so that the plotting can be done. And this is a snapshot of a plot. As you can see, this plot will be increasing in time. In real time the plot will be, we will show you the plot, and it will show you the frequencies at which the primary users are operating, and when the primary users come on, what happens to the secondary user. So in cognitive radio, the idea is that you have lots of free spectrum that is there, especially TV spectrum. So they can use that spectrum for data communication, subject to the condition that if somebody actually switches on the TV or uses that spectrum, the primary user, then the secondary user, that is the user that is using it for data communication, must move to another channel or must wait till the primary user completes. So this is currently a very popular area of research, and it is standardized as per 802.22 standard, IEEE 802.22, and the NetSim implementation of cognitive radio is again as per this standard. And in this example we are trying to just demonstrate to you how you can visualize some of the internal workings of cognitive radio by using Matlab to plot the output results. So we'll now shift to NetSim, and like I had explained earlier, NetSim comes with an inbuilt Matlab interface where we have called the Matlab APIs. So we now go and open a network scenario of cognitive radio. So this is the exact scenario that we had showed you in the presentation, and all this can be created very simply by just using the drag and drop option that is there on top. You can drag and drop any device you want from there, and we have several hundreds of videos in our channel explaining to you how you can create scenarios, how you can set properties. We'll just show it to you. There's our YouTube channel. So you can go to our website, and in our website there is under support there is videos, and this is our YouTube channel. So here we have a number of videos on cognitive radio that you can see, how you can set up various parameters in cognitive radio, how you can create scenarios, some examples about how to use it, and so on.